This is a problem from the study plan. The following data summarizes results from 1018 pedestrian deaths that were caused by accidents. If one pedestrian death is randomly selected, find the probability that the pedestrian was intoxicated or the driver was intoxicated. So here's our situation, and we're looking for this probability where we have the pedestrian was intoxicated or the driver was intoxicated. So this is the probability that the pedestrian was intoxicated or the driver was intoxicated. And because we see the word "or" here, we're going to look at the addition rule, where we're computing the probability that the pedestrian was intoxicated plus the probability that the driver was intoxicated. And there's a possibility that there might have been some overlap between these two probabilities, and so we want to subtract out that possible overlap where we counted the pedestrian intoxicated and the driver intoxicated. So we're interested in creating this table. It looks like if I add the rows and the columns, we can get some more numbers here. So adding the intoxicated drivers, there's going to be 56 and 100, and adding the non-intoxicated drivers, there's 272 and 590. So that would be 862. And if we add these two together, we should get our grand total of 1018. That's the total number in the survey. Adding the intoxicated pedestrians, we would get 328, and we would get 690. Again, adding that would give us our grand total. So if we want to look, what is our probability that we randomly select a person in this person, or in this particular accident, that the pedestrian was intoxicated? So we can look at the intoxicated pedestrians. There are a total of 328 of them out of 1018. If we randomly select a person or an accident, and in this particular accident we want to find out when the driver was intoxicated, so driver intoxicated would be the first row. There's 156 of them over 1018. Now, we added these two numbers over the grand total, but if we noted, we counted 56 twice. We counted the drivers that were intoxicated and the pedestrian intoxicated. We counted 56 when we took 328. We counted 56 when we took 156 over the big denominator. So this was counted twice, and we need to subtract that out, and that is the probability that we select a person, an accident, where the driver was intoxicated and the pedestrian was intoxicated. So all we have to do is add these. We have the same denominator, and just to add this real quick, we have 328 plus 156, and then we want to subtract out a 56. Now this is going to work because we have the same denominator. If you have different denominators, I would probably compute these individually and deal with decimals. But in this case, we have 428 divided by 1018, and if they want your answer rounded off to 3 decimal places, let's go ahead and divide this and round this off to 0.410. Okay.